All right, in video number 2, we're going to do some more practice with these new shortcut rules for sine and cosine of x, e to the x, natural log of x. I kind of want to do letter I for sure. Maybe we can do letter G to kind of get it out of the way. That's pretty easy. And then maybe H. So maybe the bottom row. Yeah. Let's do it in this order. This is the easiest one. Is it? Let's see. Finding the derivative of f. Finding the derivative of f. Well, I have a constant, so I can use that constant multiple because I'm multiplying -3 times e to the x. The constant multiple rule says hold the constant, the -3, take the derivative e to the x, and then multiply it times the constant. So e to the x is just e to the x. So this doesn't change at all. Plus, I have another constant, 4. So hold the constant times take the derivative of the natural log of x. And if you look at the top at the table on your paper, that would be 1 over x. And just like that, this is the derivative formula. Well, that's going to give me -e3 to the x plus, I'm going to go ahead and combine these two fractions and say this is 4 over x. Remember that 4 is over 1. So that's really over 1. And when I multiply fractions, I multiply straight across. So 4 times 1 is 4 on top, and 1 times x is x on the bottom. And there's my answer. So my derivative function, make sure that you write the label of what you're finding. Don't just find it. Tell me what you found. We found the derivative of f with respect to x, and this is the formula that I would use. I'm going to jump to letter I, and we're going to try to do this one. So I can use the power rule. It's already set up for me to use here. But over here, I see something weird. Unless you remember a couple of things. You might remember that the natural log of 1, this is one of those values you need to know from Algebra 2, pre-cal, that the natural log of 1 is 0. And e to the 0, any number to the 0, is 1. So this whole thing turns out to be just 1. Times 4x, that means all of this is really just 4x minus x to the -3, right? So even though it looks all complicated, maybe it does, maybe it doesn't to you, I don't know. But that is just 4x. The other way to think about it is exponentials and logarithms are inverse functions of each other, so they cancel each other out. So when I have e to the power of the natural log, whose base is e, of 1, the e and the natural log will undo themselves, and I'm just left with what's inside. So maybe that's something you need to think about, that if I ever have e to the natural log of y, my answer is just y, because e and the natural log are inverses. They're going to cancel each other out, and I'm left with whatever's inside. And the same thing happens the other way. If I take the natural log of e to the 10 power, that's just 10, because the natural log and e are inverses of each other. They're going to undo each other, and I'm just left with 10. So a little algebra review there with exponentials and logarithms, how they're inverses of each other, therefore they undo each other, and sometimes you'll see things that are a little bit simpler than what they look. All right, now I'm ready to take the derivative. The derivative of f is the derivative of 4x. If there's a 1 here, multiply 1 times 4, and that's 4. Subtract 1 from the exponent, that would be x to the 0, but x to the 0 is just 1, so it disappears. By the way, I don't know if we've talked about this, but if you think of what this looks like on a graph, what would y equals 4x look like on the graph? Wouldn't it just be a line with slope 4? So at any x value, the slope is 4. So therefore, when I see 4x, the rate of change, the slope of the tangent line is just 4. That's another way to think about it. From this one, I'm going to multiply -3 times x, but there's already a minus there, so that's going to become plus, let me change colors here, plus 3x to the power of -4. Remember, we're subtracting 1 from the exponent to get the new exponent, so -3 minus 1 is -4. Is this the answer? Most definitely. Is it simplified? Probably not to some standardized test people. So this could be rewritten as 3 over x to the fourth. And that would probably be on the multiple choice options. And then finally, we get to this one. Again, I cannot take the power rule derivative shortcut in the denominator. I also cannot do the power rule whenever I have radicals. So we need to rewrite this. Notice I'm still not taking the derivative. I don't take the derivative till down here. Right now, I'm not doing that. I'm rewriting the way it looks so that I can take the shortcut derivative. Minus, here, 4 over 5, so that's 4/5. Oh, my pen. 4/5. And then x to the negative 3, because I'm going to flip it to the top so that I can take the derivative. Minus 2x to the negative 1/2. Negative 1/2 because, again, I'm flipping the square root to the top, and square roots are the same thing as 1/2 powers. So now I have purely power functions. I can take the derivative, and we can get to the derivative function by just multiplying exponent times coefficient. I'm going to write it as 3/2 x to the negative 1/2. Remember, we're subtracting 1 from the exponent, so 1/2 minus 1 is negative 1/2. And then I'm going to multiply negative 3 times minus 4/5, so that's really plus 12/5 x to the negative 4. And then once again, I'm going to multiply negative 1/2, which is an exponent, times 2, which I'm subtracting. So that's going to turn into plus 1x to the negative 3/2, or negative 1/2, right? I had negative 1/2 minus 1. Well, that would be negative 1/2, which is negative 3/2. This would be our answer, not in simplified version according to some test makers. So let's fix it. We can fix it by getting rid of that negative exponent. So we're going to flip it back down. Except as I write it, I remember, oh, isn't a 1/2 power a square root? So why don't I write that? Plus 12 over 5 x to the positive 4. Why positive? Because we flipped it. Right now it's in the numerator. We're going to flip it to the denominator. Plus 1 over x to the 3/2. Or I could also say x to the 3/2 is the square root of x to the third. And I can call that as my answer. We're just doing more practice with the power rule, but now we're folding in some derivatives of sine x, cosine x, e to the x, and natural log of x.